Chapter 4, Probability. Session 4.1, Basic Concepts of Probability. Let's look at the definition. An event is any collection of results or outcomes of a procedure. And we have the simple event. Simple event consists of exactly one outcome. In these sessions, we're gonna study about simple event. And then session 4.2, 4.3, we're gonna talk about the compound event. Compound event is a combination of two or more simple events. And then we have the sample space. Sample space is for procedure consists of all possible simple events. Let's look at this example. If I try to perform a probability experiment, my event will be flip a coin. Okay, flip a coin will be the event. And since this event, we only can get head or tail. That will be exactly one outcome. So we call this is gonna be the simple event. And then we need to know how to write out the sample space. Sample space is talking about all the possible outcomes. So when you flip the coin, we can get either head or tail. So head or tail, that will be the sample space. Example 1. Consider the probability experiment of rolling a single fair die. Identify the outcomes of the probability experiment. What is the sample space? Define the event E will be the whole and odd number. So first, let's write out the sample space. When you roll a single fair die, we could get either 1 or 2 or 3 or 4 or 5 or 6. So my sample space, that will be 1, 2, 3, 4, 5, 6. And then my event. In this example, I'm gonna let the event E will be whole and odd number. So what is an odd number here? It will be 1 or 3 or 5. So this is gonna be my event E, odd number 1, 3, and 5. Basic probability. Given that all outcomes are equally likely, we can compute the probability of event E by the given formula. Probability of event E equal to number of ways event E can occur over total number of outcomes. So for example, if I want to flip a coin to get the tail, okay, so when I flip a coin, I only have a one tail. So number of the ways event E can occur, there'll be 1 in here. And then over total number of outcomes. So when I flip the coin, I can get either head or tail. So I do have 2 outcomes. So the answer will be 1 over 2. Okay, basic probability. Now, let's look at the notation for the probabilities. We use P stand for probability. And then you can let any events for A or B or C or even E. So when I write P of A, this is talking about probability of event A occurring. Probability of the event is always between 0 and 1. So this is very important. Keep in mind, when you calculate the probability, it has to be in between 0 and 1. If you find that is a negative number or your probability greater than 1, that means you make a mistake. Probability of an event that cannot occur is 0. So for example, when I flip the coin, I would like to get head and the tail at the same time. But I only have a one coin. It is impossible, right? Because the coin is going to be flipping over, either head or tail. We can't get both of them at the same time. So we say probability of the event that getting head and the tail at the same time will be equal to 0. Probability of an event that must occur is 1. So for example, if I flip the coin, I want to get either head or tail. Then the probability is going to be equal to 1, right? Because number of the ways event E can occur. I can get head or tail, so I do have 2 outcomes. And then total number of the outcomes is also equal to 2. So that will be 2 over 2, which is going to be equal to 1. Example 2. Consider the probability experiment of rolling a single fair die. Identify the outcomes of the probability experiment. What is the probability of rolling a 3? So before we calculate, try to write down the sample space. What you can get when you roll a single fair die. Sample space will be 1, 2, 3, 4, 5, 6. And then, what do we want to get? Our event will be getting a 3. Okay, so I let the event E equal to 3. Now, calculate the probability. Probability of 3, that will be 1 over 6. Okay, one more time, look at the basic probability formula. Number of the ways event E can occur over total number of outcomes. So we do have a 1 E here, and then we do have a 6 outcomes. So that will be 1 over 6. B. What is the probability of rolling a number larger than 4? So again, we try to write out the sample space. And then we want to get the probability that rolling a number larger than 4. Okay, larger than 4. So that will be 4, 5, and 6. So use the basic probability formula. That will be 3 over 6, which is going to be 1/2. What is the probability of rolling an even number? So again, write down the sample space. Even number, that will be 2, 4, and 6. So probability of even number will be 3 over 6, which is going to be 1/2 again. Example 3. Consider the experiment in which 2 6-sided dice are rolled. What is the sample space? So this one, you guys need to think about it. If I only have a 1 die, the sample space will be 1, 2, 3, 4, 5, 6. But right now, I do have a 2 of them. So we do have a different combination. For example, we can get 1, 1 here, or 1, 2, or 1, 3, 1, 4, 1, 5, and 1, 6. Or I can get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6 also. Okay, so I want you guys try to list out all the sample space when you roll the 2 6-sided dice. Okay, check your work. You can have a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Right? It can be 2, 1, 2, 2, 2, 3, 2, 4. So you could count how many sample space do we have? We do have a 6 times 6, which is going to be 36. After you write out the sample space, you're going to find the probability. What is the probability if the sum of two numbers equal to 4? Okay, look at it. Sum of the two numbers equal to 4. It can be 3 plus 1, 2 plus 2, or 1 plus 3. Okay, so this is gonna be my event E here. And the probability to getting two numbers is equal to 4. That will be 3 over 36. which is going to be 1/12. Example 4. When 3 children are born, find the probability of getting 3 children of all the same gender. Assume that boys and girls are equally likely. So first, I want you guys try to write out the sample space. When you have 3 children, what is the sample space? I will use the B stand for the boys, G stand for the girls. So for example, I give you the first one. It can be boy, boy, boy. Or it can be boy first and then boy again and then girl. Or boy, girl, girl. Okay, try to write it out all the combination and then count how many of them in the sample space. So second one, it can be boy, boy, girl, boy, girl, boy, or boy, girl, girl. Keep going to write the rest of it. Okay, so double check I didn't duplicate any one of it. So I do have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I do have an 8 total outcome. And then what we are looking for, we want to find the probability of getting 3 children of all the same gender. So all the same gender, it can be all boys or all girls. So probability, that will be equal to 2/8, which is going to be 1/4. When you guys try to find the probability, I need to see this. What you looking for? P of what you looking for equal to, so your word and your final answer. A standard debt of 52 playing cards is commonly used when calculating probabilities. Please note that the following. There are 4 suits: hearts, spades, diamond, and clubs. And this is gonna be their symbols. Spades and clubs are black, while hearts and diamonds are red. Each suit contains 13 cards. So that will be the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then jack, queen, and then the king. So total we do have 52 playing cards. If you guys never play with the playing cards, you could look at this picture here. Okay, try this example. Hannah has a deck of 52 cards and wants his friend Sheldon to draw a card. Calculate the probability of drawing a queen of diamonds. Okay, so look at the picture. A queen of diamond. We only have a 1, right? So that will be 1 over total number of playing cards, which is going to be 52. And then 1 to the 4 decimal space. B. Calculate the probability of drawing a 9. Okay, so look at here, drawing a 9. I do have 1, 2, 3, 4. Okay, 4, 9 over 52 cards. Then last one, calculate the probability of drawing a club. Okay, think about it. How many clubs in a 52 daring cards? We do have a 13, right? So 13 over 52. Example 5. A survey was taken of drivers admitting to running a red light in the past year. The number of yes response was 500 and the number of no response was 213. Find the probability that if a person is chosen at random, he or she has won a wet night in the last year. 1 to 4 decimal space. Okay, so think about it. What is your total outcome? Total outcome will be the number of yes responses 500 plus the number of a no response was 213. So add it two up, that will be your total outcomes. And then think about it. What is the probability if a person chosen at random, he or she has won a wet night? Okay, won a wet night, that will be 500. Use your calculator, you should get 0.7013. Complementary events. Suppose an event Y occurs. The complement of event Y is the event Y does not occur. For example, if I say it will rain tomorrow, what is the complement of it will rain tomorrow? That will be it will not rain tomorrow. Okay, so rain and not rain, that will be the complement. And for the notation, we do have the Y bar here. This is represent the complement. You could think about it, that will be the opposite of the event Y here. The probability of the complement is given by P of the complement of Y equal to 1 minus P of Y. Okay, or another way around. For example, if I say there are 40% it will rain tomorrow, what is the complement? The complement will be 1 minus 40%, which is going to be 60%, right? If I say 40% it will rain tomorrow, then 60% it will not rain tomorrow. So we call this as complementary events. Example 6. Hannah has a deck of 52 standard cards and warned his friend Sheldon not to draw a king. What is probability for Sheldon not to draw a king? 1 to 4 decimal space. So when you see the questions with not, you could think about the complement formula. Let's write down the complement formula. Probability that not to draw a king. Okay, so this is what we're looking for. Equal to 1 minus probability that draw a king. So think about it. If you want to draw a king from 52 playing cards, what is the probability? We do have 4 kings, right? Out of 52. Get the same denominator, that will be 52 over 52 minus 4 over 52, which is going to be 12 over 13. 1 to the 4 decimal space, you're going to get this. 0.9231. So for these sessions, we learned the basic probability. That's it.